Shalom, welcome to the Jewish View. My name is Rabbi Nachman Simon with the Chabad House of Delmar, together with my co-host Mark Rohrich of Statewide News Service and jbiztechvalley.com. We have a very, very special guest with us, Dr. Farb, of CEO of Leviathan Energy. So I got that right. They're a good energy company. We need a lot of energy in the United States now. So I'm glad.
I need energy too.
Physical energy, but you're with the physical energy.
Well, scientific energy.
Scientific. What, Dr. Farb, tell the audience, what is your, how did you get to this point? You know, you grew up on the Upper West Side,
right,
and in Manhattan, and what brought you to Israel, and now you're going to be coming back?
So I've been all over. I think my background is very varied. Maybe we should do what they call in medias res, begin with what's most relevant to us, and then sort of you'll see how it fits in. Because people don't usually believe me.
Well, your educational background, for example.
My educational background is, I have 3 degrees. One is English literature from Yale, the other is business from UCLA, and the other is medicine from Boston University.
That's 3 varied degrees, I'll say that.
So I've always been a multidisciplinary person.
So why didn't you become a doctor?
I did. I practiced.
Oh, you did? What was your specialty?
Ophthalmology.
Oh, you see eye to eye with people?
Yeah, I do. Eyes are the windows of the soul, right?
That's right. Eyes are the windows of the soul.
But really what you're saying, you're now in energy, and energy is a super hot market now.
Right.
I mean, especially in America, around the world, everybody's dying for oil, and they're looking for natural gas. Fracking is a big issue in New York State. So energy is really the hot issue. So what's your company do, and how does it help the energy crisis? I don't know if it's a crisis, but it's an energy problem.
So I'm one of those save the world type of people, and I got very interested in renewable energy, and I've always been interested in ecology, and I love the outdoors. I'm a big hiker, and I also grew up in an environment. My father was one of the first people in the press to make a big deal about ecology in the United States.
Yeah, they don't call it ecology anymore, so that's a 1970s term.
Conservation,
yes, but I'm saying that's a 1970s term, ecology.
So you have a feeling for that's why you went into the area.
Well, I was interested in it, and I feel that it's a major priority for Israel and the United States to be more independent of oil and other resources like that are undependable or not good for the environment. I mean, we're seeing more and more now about how even if we have our own internal supplies, should we be using them because it's destroying the environment, it's causing melting of the polar ice caps, it's causing all sorts of climate change. So I felt that I could make a big difference by turning my attention to ways in which we could develop clean energy, and not just to make a little improvement here or there, but to make major improvements on a big scale in many different technologies.
And you decided this about 10 years ago? Or?
After I moved to Israel 8 years ago, and while I was there, I started writing my patents around 7 years ago.
And you have 50 of them?
Around 30.
Around 30?
Only 30.
I read 50 somewhere, but okay. So how are you, so what focus do you have? Because there's wind, there's nuclear, there's solar, there's different types of energy.
Only clean things that have the potential for high efficiency. So that means no solar, because solar is low efficiency, and no nuclear, no biogas, because that's all burning stuff. I mean, I may get involved in it later, but basically it's making wind, hydro, underwater, and wave turbines much more efficient.
How about geothermal?
I haven't done geothermal yet, but there's a great Israeli company that does that very well.
Oh, I didn't. Okay.
So it's called Ormat. So no need to step on their toes.
Okay.
But basically, to explain to you what I'm doing scientifically in simple terms, the basic power output equation is proportional to the velocity cubed. It has a linear relationship with everything else. What that means, for example, if 1 meter per second of wind could light 1 light bulb, 2 meters per second of wind is 2 times 2 times 2 it can light 8 light bulbs. So if I can increase the velocity to the blades by making a better turbine and better geometries and so forth, in many different ways, I can make major changes in renewable energy. So I can go specifically through the different technologies, but the basic point is that by using new designs and using a discipline called computational fluid dynamics to model them on computers, I've got inventions that can make major changes, very large improvements in the power output and efficiency. So that's the basic idea. We could go through them specifically. I think people would be interested.
There are wind turbines now. You go to a few places and you see those windmills
Right.
flowing around. So yours is much better, you're saying. It's not just another product on there.
Right. So let me explain what I'm doing for wind. So for the large wind turbines, I don't make turbines. I don't even touch the turbine. Can you guess what I'm doing?
No.
What I do is I make computer models of the wind and the turbine, and we make large structures, maybe 50 to 100 meters away, that have an impact on the wind by the time that it hits the turbine, so that its velocity is increased in the plane of the blades. It's all complicated computer modeling and geometry. However, it's very, very effective. We tested that with a control turbine and a test turbine side by side in the Negev a few years ago. And we found that in general, it produces at least 20 to 40% more power based on using these models. So
you need a lot of wind where you went to the Negev because there's a lot of wind?
No, there's actually little wind there. And in cases where there's little wind, like most of the time in the Negev, we found that the increase in power was 100% or more because it has a greater effect on low wind velocities than on high wind velocities, which is very important, and especially for the state of New York, because there are many locations here and, of course, all around the world where by being able to run turbines profitably at lower wind speeds, you open up whole new areas that people thought were not economic for building wind farms, and now you can. And wind is, large wind turbines are the fastest type of, fastest growing wind energy around, and and fastest type of renewable energy around, and they're already connected to the grid, and we can go and retrofit all of them and quickly improve their power output by 20 to 40%. It can make a very significant difference for the country.
So let me, are you talking about 3-blade?
Yeah, the 3 blades. I said we don't touch the turbine.
No, but how
we
many
can work
blades
with
are you
any
talking?
turbine, with a big 3-bladed turbine.
Okay. Now, you're doing, sounds like wonderful work. I was following it all the way through.
Yeah.
But what about these environmentalists who say that it ruins the landscape of the beautiful, let's say, Adirondack Mountains or any other mountain range, as opposed to someone else who sees this as being an artistic, a piece of artwork that adds to the aesthetic value of the mountain range? Which, I mean, you got both arguments on both sides. Here you are being the scientist, and then you go you look up and you go, oh, they're not appreciating my work. They're, I'm hearing this from people who care about the aesthetic value. I want to save, the world here, with clean energy. So how do you react to something like that?
So I have 2 ways of reacting. Number one is that I myself am an environmentalist. But I believe that all of the coal production and everything else is killing more birds than the occasional stupid bird that wanders into a windmill. So there's no comparison. And I think that those people who call themselves conservationists and put us in the position of delaying renewable clean energies because of this are not really conservationists. They don't.
And what about the aesthetic value of how it looks in a mountain
Well, that's up to everybody else, but I'm approaching the aesthetic issue in a different way. I
Yeah.
also have small wind turbines
Oh, you do? Okay.
that we're designing to be beautiful. They're the most beautiful wind turbines in the world, I think.
So
you know?
because you want to have them blend in with the greenery of the
Well,
mountains, or?
Well, the small wind, yes, but also they're made for an urban environment or for housing and so forth,
I see.
so that they enhance the value of the house or the
I'd
factory.
rather see a
or whatever.
windmill on my house as opposed to the solar panels on my roof, quite frankly. And you're saying the solar panels are inefficient.
They're well, it depends where. In New York, it's crazy.
New York city or state?
The whole of New York. We're
All of New York.
45 degrees latitude
Uh-huh.
from the equator. There's not much sun here.
Okay.
It's not that efficient. Now, wind in many places is, but I believe in both. I believe there's a place for solar and a place for wind, and they actually work well together.
Okay.
But what I'm saying is that this is not the best environment for solar. This is, in general, in New York State, it's a better environment for wind. In general, not in all cases.
Do you know that there's a ski resort in Vermont or I think it was Vermont, that reduced its cost significantly, energy cost significantly, because they put in wind turbines, and their ski resort is being operated by the energy they get from the wind turbines.
That's great.
Yeah.
I'm in favor of that.
But working on what you just said, just let's get into practical. You say you could put it on your own home. Let's say a person had a nice big home and
Yes, they
like
could.
myself over here, yeah, a nice one home. So yeah, tell me how it would work. I mean, how are you going to save energy and
Okay, so
the cost?
So for our small turbines, we call them wind tulips because they're shaped like tulips and they're very pretty. And that's part of what we're doing. They also happen to be aerodynamically a little bit more efficient than similar types, but they have some other advantages over other types of turbines. Number one is they start at lower speeds. We've clocked our latest one that's hopefully we'll be bringing some to the United States this year that starts at 1.2 meters per second wind. Most wind turbines start at 3. Okay, so we're in good shape there.
What's the?
But
Go ahead.
there's something else that's really important that we're doing, is that we've designed them so that the aerodynamics, instead of one wind turbine interfering with each other and having to place them far apart, one from the other, is that by placing them at the right distance from each other, they improve the power output of the one next to them by creating wind tunnels that funnel the wind into the next
The
one.
kind of idea like when you're bicycling behind a bus, is that kind
Right.
of the idea that you're just carried along with.
In reverse,
Right,
kind
yeah.
of, yeah. In other words, it's the whole idea of whether or not you have aerodynamic interference or lack of interference.
Right.
So that's the same principle, same idea as why jet fighters go in squadrons or birds fly
In
the way
that
they
V
fly.
shape, yeah.
They create a whole field of aerodynamics that you can't see but exists all around them, and they take advantage of that. So in the same way, we're taking advantage of the environment that each wind turbine creates. And that's something that's unique. So we're certainly glad to sell to you if you want to put one on your house, but they're made for flat roofs, and the major audience is for real estate, commercial real estate, factories, malls, and so forth, where we can put 10, 20, 30, 40, 100 at one go, and we can make a significant impact by doing enough of these around the country.
And you know, the tulip is the city of Albany's flower.
I didn't know
and
that.
we have a tulip festival and all that. So, you know, if you had like Crossgates Mall, the roof of Crossgates Mall with all these tulip-shaped windmills, you know, I think they would be great because it would have a real significance in terms of our Dutch heritage and, you know, everything that we
We'll
offer.
tell them to buy some.
Well, there you go. I'll work on that.
They're working on expanding over here, their new
Yeah.
wing.
I'll work on that. What else? So when you talk about the lower airspeed that needs to be, you said what, 1.2 meters or whatever. What is that in terms of miles, wind speeds, miles per hour? Like we have a wind gust of 4 miles an hour or 10 miles an hour, and We talk in those terms here in the United States.
You know,
so
I'm not that good at calculating in my head.
what would you think it would be, the approximate?
Just small little breeze, you're saying?
It's a tiny breeze. Yeah,
Really,
it's a tiny
that's all it
breeze.
is?
It
Yeah.
would
Maybe 3 miles an hour.
would create enough energy to move the wind.
It's enough to move it and create a few watts.
Right.
Not much, but the point is, for most other turbines, at 3 meters per second, or I guess maybe 6 miles per hour, is when they're just starting.
Mhm.
So it's like having, in a race, it doesn't hurt to be ahead a little bit when you start.
Well, I'll tell you that the University at Albany campus, which I don't know if you've seen while you
This is
were
my
here.
first trip to Albany.
Oh, well, I got to take you around and give you my tour.
Uh-huh.
But the University at Albany
Yeah.
campus was actually built for the dry, arid atmosphere of New Mexico.
Uh-huh.
And then Edward Durrell Stone, who was the architect and working with Governor Rockefeller, they saw these plans, and Rockefeller wanted this for Albany.
Uh-huh.
Well, what that campus design was for is to trap the wind in New Mexico. We don't need to trap the wind here in Albany, but it does trap the wind. And it is extremely gusty at times on the SUNY Albany campus. So I would think that would be a perfect place to capture. You put some of these windmills in the center courtyard of the quadrants.
Yeah.
And, you can save, probably SUNY could save some money on, their energy
Well,
bill.
it would also act as a windbreaker.
Right.
So we actually have one running like that. One of our older versions is at a hotel in Eilat in Israel, and the hotel administration just enjoys having it there to partially break the wind.
But so it is cost efficient, though, bottom line. I mean, there is, people are going to look at that. How much does your apparatus cost, number one, and how much are they saving, getting down to the bottom line?
So there are a few inputs to that, and one is the wind speed. That's very important. Another is the cost of the turbine and the installation. Another is the subsidy or tariff.
Mm-hmm.
How much do they pay you for the electricity? Do they pay you
Who's they?
They?
The
The electric company or the state.
Okay.
Sometimes there's subsidies. There's a federal government tax credit. In many cases, in New York, you can get NYSERDA to help you with the costs. So all of these inputs come together.
But generally speaking, again, I'm using general numbers. Are we talking about $1 million a turbine, $100,000 a turbine? I mean, $10,000 a turbine? I mean, give me some range of, generality of.
So for our small wind turbine, our plan is to sell the turbine itself for $7,500 each for 2 kilowatts of capacity. Doesn't mean it produces 2 kilowatts all the time, but the capacity to handle 2 kilowatts. And to put those in clusters, as I said. So when you put them in clusters, it decreases the installation costs.
Right.
Because
But is the $7,500 including the installation cost?
no, it's
Okay.
not just for the turbine.
So when you're talking about the total package, let's say that a company like Crossgate Small Pyramid Companies or some other company might have to think about investing, whether it's the credits come, they're minor anyway. They,
Yeah.
they're just feel-good credits, so in New York State at least.
I don't know, it's pretty good. NYSERDA sometimes gives 50%. That's pretty good.
Okay, but then they probably have some, they probably hedge, has to generate X number. I mean, they're just not giving 50%, so.
You have to pass some hurdles
Right.
of certification
Yeah.
and so forth. We're not there yet because we're
Right.
too new for it. It depends. As I say, there are several factors, and each case is different. But in general, if you have strong winds for a good part of the year,
Right.
you're very likely to make good money on it.
So you can recoup the expense of the installation of the whole apparatus, within 10 years, 5 years?
So it depends. Let me give you an example from Israel, because I've been working closely in Israel.
Sure.
And we're actually are launching right now an investment fund to invest in small wind farms all over the world, but particularly in Israel and the US. So the economics of it in Israel are that there are some very good areas where the wind is such that each one of our turbines could produce, picking an easy number, let's say 5,000 kilowatt hours per year. They're paying around 45 cents US per kilowatt hour. Let's just round it up to 50 cents to make it easy to work with. So that means that each turbine would be producing $2,500 per year. So if you're paying $7,500 for the turbine, plus $2,500 for the installation, you've put in $10,000, and you're producing $2,500 per
So you
year.
get 4 years.
That's
give or take.
25% per
Right,
year.
right.
I don't think our banks offer
No,
that.
That's right. That's right.
Even junk bonds can't come close to that. And in Israel, there's a 20-year contract with the electric company that the government has mandated that you have a 20-year contract where you're making this kind of money. So let's say that not every area is that good. So you're making 20%. Between friends, what's 20%? You know, it doesn't hurt. You know, it's not bad. And you know, people would die for that kind of return.
Yes.
So it depends where you go, what the subsidy
Sure.
is, what the tariff is, what the wind speed
So it
is.
sounds like it's between 5 and 10 years you can recoup your investment.
Right.
That's what it
That's
sounds
not
like.
bad.
Yeah.
That's pretty good. But, I mean, is there storage? Let's say, for example, again, Mark's been using the cross gizmo. So you have them all, and it's working all your turbines, and it's, I don't know the weather, but one night is just dead over here.
Yeah.
Nothing's happening for 10 hours or whatever. It's
Yeah.
just a dead night. You know, nothing's happening. So what happens to the electricity? I mean, it's,
So usually what they'll do is they're connected to the national grid.
so you can it'll pick
Which
up.
is the name
So-
of our utility.
Yes, also, right, pun intended. You know, what you do is you buy from them when you need, and you produce for yourself when you need.
Right.
It could just kick in whenever it needs it.
Right, that's what they call net metering. In other words,
Right.
that you supply when you have, and you buy when you don't have.
That's interesting.
Yeah.
You know, just as I started to show, energy is such a big issue today. I mean, you're not, like I say, it's a hot issue, if we can use that pun also.
Yes.
Because, you know, we see the world, I mean, it's not just the United States. I mean, these are major issues today, and the cost of energy, number one, is high, and you never know with international tensions what could really happen. Our supply, it would just only behoove the United States, I think, to be energy independent.
It's very important. You know, this is an issue right now in Europe because Russia holds the key to the natural gas in Europe. And you know what's happening there. I mean, this is how they're exerting control over both Eastern Europe and the response of Western Europe to the politics and the invasion that went on. And one of the reasons why Western Europe has been very muted in their response
Right.
has been that they don't want Putin to turn off their gas.
The spigot. Yeah, that's right.
And that's one of the reasons why Germany is very smart. And Germany is putting in as much capacity as quickly as they can with wind, solar, all kinds of renewables.
I heard that they cut out nuclear altogether.
They want to. I don't know if they have
Really,
yet.
maybe they're trying to. Yeah, it can't do it overnight.
So let me get your opinion briefly on,
Okay.
is nuclear safe? Is it not safe?
You know, it's been pretty safe.
Yeah.
It wasn't too safe in Japan, but when you look at the hundreds of nuclear plants all around the world,
Yeah.
it's done pretty well.
3 Mile Island, right? In Harrisburg, right? Not,
Those
you
are
know.
the exceptions. But one
exactly.
exception can be,
Ruin your day
devastating.
over.
yeah, ruin your day, maybe the rest of your life.
Now, I got a little bit of a tidbit
Yeah.
in that the last, you know, do you think the Obama administration is a good, is an administration that's focused more on renewables than Bush or Clinton or Ford?
Yeah,
or-
they definitely have been, and that's one of the areas that I would say they've done a good job in.
Okay,
I'm
so-
not sure about other areas.
Well, Jimmy
But-
Carter had a very good renewable energy policy that he tried to implement in the late 70s. And I don't know if you followed that back then, but
Um,
my uncle was involved with the U.S.
Yeah.
Department of Energy, and that's when I first heard about the geothermal, and we should dig deep into the core of the earth and extract that energy because it's free and it's plentiful and it's never going to run out, and the earth is not going to sort of crash into,
Collapse.
implode or whatever. Yeah.
Um,
So anyway, what I wanted to say is that Jimmy Carter is a physicist by trade, by profession.
Yeah.
So when Montreal had a nuclear meltdown, they called on Jimmy Carter to go up there and to solve it, and he solved it. He solved the problem just moments before they had the core melted. So,
That's interesting.
yeah. That was. I was
But I have something to say about that. I think that geothermal is not the total solution, because if we did it with everything, we would be releasing more heat into the atmosphere.
okay.
I think it's part of the solution. I think we have to have many different parts of the solution. We need wind, we need hydroelectric, we need geothermal, we need solar. We need everything in different locations. One
Right.
is better than another. And having many different types decreases the lack of reliability of the different modalities.
Have you studied New York State's varied energy plans? Because we have obviously Niagara Falls, we have a hydro plant in St. Lawrence, and we have 4 nuclear plants in the state, maybe 5. We have Rochester has Ginna and Syracuse. Oswego has 9 mile, we
Yeah.
call it. And then there's down in Westchester, they got the Indian Point,
Yeah.
So
But that's
they,
being closed.
allegedly. Until it happens, I don't believe
Yeah.
anything like that. So, but so Indian Point, and then so you got the 3 9 mile, you got the 2 in Rochester, Ginna, and then you got Indian Point. So you got 6 nuclear reactors in New York State, plus a lot of wind, a lot of solar. Like you said, NYSERDA's giving these tax breaks and giving money to help to develop those.
That's a multi-pronged.
So
effort.
is
That's
is New
really
York going in the right direction?
I think in general they are. You see, nuclear obviously can be very, very unsafe. And I'm developing some things that I think would help New York tremendously, like the wind, the big wind. It opens up many more areas of the farmland in upstate New York that could produce wind electricity. The small wind can be placed all over for distributed generation, make a significant impact. I also have another company that does hydroelectric within piping systems. And we can convert the water that's already captured in all the pipes that are coming down from the Adirondacks and elsewhere, where there are points of excess pressure. That can create a significant amount of megawattage.
Really?
Here.
That's interesting. Through the pipes, you mean, just even
Yeah.
through the pipes?
Right. Because every piping system has places where there's too much pressure. And now they use pressure breakers to waste the pressure. This is like a pressure breaker that makes money, and makes electricity. So that's very important. And another one of my technologies, which is, I think, very useful for New York State, is underwater. You have the Hudson River, you have other rivers here where we can put turbines under the water.
Because taking the tides, where would be the energy in the tides?
Tides also, the same turbine works with tides. And the US Navy did an evaluation of it, and they said it's 50% more effective than anything on the market.
Yeah, I like
That's
that.
great.
So I'm trying to, right now, this past week I did a tour of some possible locations in New York where we can put some small ones like this. And so I'm working on trying to get that technology in small. But certainly my eyes are on the Hudson River.
Right.
And, there are lots of other big rivers around here too.
So in the moments that we have left, how did you come up with the word Leviathan? Can you tell the audience the derivation of what that word means?
So I'd say that Leviathan is used in the Bible, and it's used in Psalms, It's used as, the Leviathan in the Great Sea. It's used in the book of Job, where can you contain the Leviathan with a pruning hook,
And what is the
And
translation of that word?
Leviathan, it's a huge fish, that's what it means. But it suggests flow, power, and all these things. And it also suggests my feeling that I was granted a gift from God to be able to understand science. And I believe that science is an expression of the incredible way in which God created the universe.
Well, that's why your logo is a fish.
Yes.
Okay, so I think at this
A
point...
whale.
Yeah, whale, that's right.
But a Leviathan is not necessarily a whale.
No, that's why I just said a fish. I didn't want to
Yeah.
get too technical, too specific, but you got to give him a blessing.
Well,
now.
listen, we're out of time, and we wish you
okay.
the best of success. That's our blessing to you, and because it's not only obviously good for you that your company flourishes, but good for the people of New York State and really the entire country and the world if we have these renewable energies that are helping the environment. And since you're going to be moving to New York, we're going to check in with you in the future to see how everything is going.
And
So
hopefully
thank you
you'll
very
be
much.
back. Thank you for
Okay.
coming. Thank you.
Thank you.